Bulk modulus is the modulus of elasticity, which can be defined as B equal to minus delta P by delta V by V. Here delta P is the volume stress and it is equal to the change in pressure, and because of this change in pressure there will be a change in volume, that is delta V by V, it is the volume strain. And because on increasing the pressure volume decreases, that's why the negative sign refers that there is decrease in volume if pressure is increased. And compressibility is defined as K equal to inverse of the bulk modulus. So we will do some problem based on these two concepts of the bulk modulus, which is the ratio of the volume stress and volume strain, and the compressibility, which is the inverse of the bulk modulus. First question is, a given quantity of an ideal gas is at pressure P and absolute temperature T. The isothermal bulk modulus of the gas is. For ideal gas, equation is PV equal to nRT. P is the pressure, V is the volume, T is the temperature of the gas, N is the number of mole of the gas, and R is the universal gas constant. And for isothermal process, temperature is constant. Therefore, this right hand side term is a constant term. Therefore, on taking the partial differentiation, we will have differential of PV will be equal to differential of nRT. And differential of a constant is 0, so this right hand side term will be 0. We will have differential of PV is equal to 0. This implies that on differentiating PV, we take first P, then differential of V, plus then V and differential of P, and it will be 0. This can be written as P dV equal to minus V dP, or P into dV by V equal to minus dP, and finally we can write that minus dP by dV by V, it is equal to P, and this left hand side term is the bulk modulus. So bulk modulus of the gas in the isothermal process is P equal to P, that is the pressure. So option B is the correct option. And suppose instead of the isothermal bulk modulus, it is asked to find the adiabatic bulk modulus, that is process is adiabatic process. For adiabatic process, we know the equation is PV gamma equal to constant, where gamma is the ratio of the specific heat at constant pressure and constant volume. This implies that on differentiating, we will have differential of PV gamma equal to differential of constant, and differential of constant is 0. So we can write that this implies that P into differential of V gamma plus V raised to power gamma and differential of P. It will be 0. We can write it as P into gamma V gamma minus 1 into dV plus V gamma into dP equal to 0. Here V raised to power gamma minus 1 is constant, so we will have gamma P into dV plus V into dP equal to 0. This implies that because volume is not 0, hence gamma P into dV plus V dP will be equal to 0. This implies that gamma P into dV will be equal to minus V dP, or we can write it as gamma P into dV by V equal to minus dP. Therefore, minus dP by dV by V, which is the bulk modulus, that is equal to gamma P. So in case of the adiabatic process, the bulk modulus will be equal to gamma P, while in case of the isothermal process, bulk modulus will be P, pressure. Next question is, the bulk modulus of the spherical object is B. If it is subject to a uniform pressure P, the fractional decrease in the radius is. Formula is B equal to minus. If pressure applied is P, then change in the volume is dV by B. Minus sign is used that on applying the pressure, volume will decrease. We know for a spherical object volume is 4 by 3 pi r cube. Therefore, on taking the log on both sides, it will be log V equal to log of 4 by 3 pi r cube, which can be written from the formula of log mn equal to log m plus log n. So it is log of 4 by 3 pi plus log of r cube, and it is equal to log of 4 by 3 pi plus. This is the formula of the shape log m raised to the power n. So it is n log m. We can write it is 3 log r. Now taking the partial differentiation on both sides, we will have dv by v is equal to 0 plus 3 into dr by r. Therefore, dv by v will be equal to, that is fractional change in volume will be equal to 3 times in the fractional change in the radius of the sphere object. So we will replace here, it is equal to minus p by 3 into dv by, this is dr by r. So it implies that dr by r will be equal to minus p of 3 into b, and because there is a decrease in the radius, so it is minus dr by r will be equal to p by 3b. Hence option C is the correct option. Next question is, a cube is subjected to a uniform volume compression. If the side of the cube decreases by 2%, the bulk strain is. The strain is delta V by V, that is fractional change in the volume. And for cube, volume is the cube of the side. So we can write it is log V equal to log of A cube. And this can be written as 3 log A. Now taking the partial differentiation on both sides, we will have dV by V will be equal to 3 into dA by A. Therefore, we can replace here this dV by V by 3 into dA by A. This is the fractional change in the side, and it is given that the side changes by 2%. That means it is 3 into 2 by 100. So it will be equal to 0.06. Hence, option D is the correct option. Next question is, a solid sphere of radius r made of soft material of bulk modulus k is surrounded by a liquid in a cylindrical container. A massless piston of area A floats on the surface of the liquid, covering entire cross section of the cylindrical container. When a mass m is placed on the surface of the piston to compress the liquid, the fractional decrement in the radius of the sphere is. So it is the case of bulk modulus, where bulk modulus k is given and it is equal to, in terms of magnitude, the change in pressure divided by the volume strain. So it will be equal to, here mass m is placed on the surface of piston which causes the pressure. So we will have the force is mg, this is the weight of the placed mass, and this force act on the area of the piston, that is A. So mg by A is the applied pressure, and because of this pressure there is a change in the volume, and it is the volume strain delta V by V. And we know that for a solid sphere, volume is 4 by 3 pi r cube. So fractional change in volume by delta V by V will be equal to 3 times of the delta R by R as done earlier question. So we can write it is equal to mg by A divided by 3 into delta R by R. Here we can write that it is equal to mg by 3a into delta R by R, because we have to find the fractional decrement in the radius of the sphere. So this implies that delta R by R is equal to mg by 3a into k. So hence option C is the correct option. Next question is, an external pressure P is applied on a cube at 0 degrees Celsius so that it equally compressed from all sides. K is the bulk modulus of the material of the cube, and alpha is its coefficient of linear expansion. Suppose we want to bring the cube to its original size by heating. The temperature should be raised by. Here, on applying the pressure, there is a compression, so decrease in the volume causing the decrease in the side. Therefore, we can write that bulk modulus K will be equal to applied pressure is P, and because of this pressure there is a decrease in volume, that is delta V by V. And for cube, volume is cube of the side, so we can write log V will be equal to log of A cube, and this will be equal to 3 of log A. Taking the partial differentiation on both sides, we will have delta V by V, and it will be equal to 3 into delta A by A. So we can replace this delta V by V in terms of side of the cube. It will be P by 3 into delta A by A. This implies that fractional change in the length of the side of the cube delta A by A is equal to P by 3K. This is our equation number 1. And to get same length, we have to increase the temperature, and from the formula that change in the length delta L is equal to original length into coefficient of linear expansion and temperature change. This is the formula. So applying this formula, in present case we will have that our side is A, so change in the length, that is delta A, and original length of the side is A, into coefficient of linear expansion is alpha, and final temperature is T, and initial temperature is given 0. So this implies that we have delta A by A is equal to alpha into T. This is our equation number 1. Now equating the equation number 1 and 2, we will have that alpha into T is equal to P by 3K. This implies that T will be equal to P by 3K into alpha. So option D is the correct option.